Hello, everybody. This is Carol speaking. Welcome to our new series of PolyWorks webinar. It's really great to see all of you logged in, so thank you for joining us this morning. Today, we are talking about how to inspect parts by scanning without using CAD models. Let's welcome Joshua Pepper as he is our presenter today. Joshua is a member of the technical support group. Let me remind you that if you have any questions during the webinar, please use the questions panel. And yes, we have kept the same format, so I will be monitoring the questions throughout the webinar, have a short Q&A session at the end, and if we don't have time to answer all of the questions, we will get back to you by email. And yes, we are recording this webinar, so it will be available for later viewing. So Joshua, it's all yours.
Thank you, Carol. Oftentimes, when we are inspecting 3D parts in PolyWorks Inspector, we may have become accustomed to having a CAD model to facilitate that inspection. However, there may be times where we don't have a CAD model accessible to us, as perhaps one cannot be shared due to security concerns, or perhaps one cannot simply be provided. Here before us, one cannot be provided due to security concerns, or one has not been produced for the part. So here before us, I have a 3D scan of a part that we are producing for one of our customers. It's going into an engine, and I will be asked to inspect this part by our customer, but they do not have a CAD to provide to us. However, they have asked for us to inspect this part to this print they have provided. So let's take a quick look at this print to see what they're after. First thing we're asked to check is the angle between two planar surfaces that lie on a flange, a machined flange here. We are asked to check the size of a hole that lies near that flange, the flatness of a surface that 4 bolt holes lie on, where we have to check the size of those 4 bolt holes, as well as a couple of distance relationships between a couple of those holes. So let's go back to PolyWorks and take a look at how we can inspect this part to meet the print specifications. First, let's take a look at the back side here, where I want to focus in on creating the 2 planes to measure the angle. Before we measure the angle, we have to create the planes. And I want to make sure I have planes that are fitted very well to the shape of my part. Well, we can use a function, extract from polygonal models, where I can easily, using my scroll wheel, make a selection zone, left click, and we can see data points being selected. Dark green points in my selection zone tell PolyWorks what kind of data I'm looking for, and finds these bright green data points that correspond, having the same characteristics as the dark green points. If I right click, PolyWorks will make a decision as to what type of surface-based feature should be fitted to those points. As we can see here, PolyWorks fitted a plane to those points. Moving on, if I go ahead and grab the data up here, we can see PolyWorks is going to try to once again find these bright green points. But sometimes PolyWorks is not going to be able to find all the connecting data points that share the characteristics that we might be after. Well, let me introduce a method called multiple detection zones. Here, what we can do is I can try to select the same area. And of course, now that I clicked that, of course, now we were able to collect all the data. Most likely PolyWorks was able to reanalyze, or I made a slight different selection here. But if I needed to, I could have come over here and made another selection to get those better points. So let's go ahead and confirm that plane there. And now that I have those 2 planes created, let's go ahead and drop in and create my angle. So I'm going to just go ahead and simply drop my angle. Now, as I mentioned, we may be accustomed to having a CAD model where we are provided nominal information. Well, I do have a print before me that is providing that nominal information. So would it not be nice for us to have geometry controls where we can still enter the nominal values of these measurements? And of course, the tolerance is plus or minus 1, so I can just go ahead and leave that. But we still get deviation results, as well as identifying what features pass and fail, so we can feed this into our control views or our reports later on down the road. Moving on, let's take a look at the size of the hole that we're asked to check here. And let me just go ahead and hide features I've already created, and let's come down here. Once again, I want to check the size of this hole using a surface-based feature, in this case a cylinder. So I'm going to go back to the extract from polygonal models, And let's go ahead and try it on single detection and see what we can get. So if I come in here and make a selection of data points here, let's say, well, I'm going to get a message that tells me the primitive type cannot be deduced. What's most likely happening is PolyWorks is unable to decide what type of surface-based feature should be fitted through the points I've selected. Let me go ahead and help PolyWorks out and define the feature that should be fitted to the points as cylinder. Let's make the same selection, and now we can start seeing a cylinder fitted to those points. However, as before, when I went to create that second plane, we're still having the same problem where we don't have data points on these other surfaces. Here, the cause of that most likely is due to the surfaces not being connected. Let's use our multiple method practice and, multiple surfaces, and now I can come in here and now I can make a selection on these other areas of my hole where we can start getting a better fit cylinder. Every time I select more data, I'm reanalyzing the character of the data to understand better how to fit the cylinder. I'm happy with that, so let's confirm that and enter the nominal value for that hole as well. Plus or minus 0.5 is the tolerance here. And let's go ahead and let's finish the print inspection on the front mating plate here that holds our 4 bolt holes. The first thing that we're asked to check is the flatness of this surface here. So let's go ahead and just switch everything back to default, as I'm fairly confident we can grab this plane quite easily, and we do so. Now, before I continue creating more features on this part, I'm constantly having to go up and pull open my features and create anything that I need. I want to make things easy for us, so I'm going to go ahead and right-click on the toolbars, and let's bring open the features toolbar where I can easily drop this to the left over here, and now I can much more easily select features that I want to create. So let's go back and add flatness to our plane down here, the GD&T control for flatness. So next we need to check the size of the 4 bolt holes, and we're going to do that through identifying them as circles. Up till now, we've been using our trusty little extract from polygonal models, but you can see we can only create surface-based features. We can't grab circles. So let's go ahead and drop down to create a circle, but we can't use a pick on CAD model because we don't have a CAD. But what we can do is switch our method to fit, and we could fit a circle to the data. So let's go ahead and, as you may know, we always want to have a constraining plane for curve-based features. Circles are that. And what I can do is I can select the elements, the data points that make up my scan using my select elements. If I make a selection, you can see I'm selecting successfully all the data points around the side walls of the hole, as well as some top surface points. So what I can do is I can go ahead and hit create, and we drop a circle in there. So very easy to do this. So let me go ahead and just bang out these other 3 circles quickly, just using the element select tool. And we have one more. With those 4 holes created, let's go ahead and enter those geometry controls for those 4 holes as well. The diameter is 6.75 and a tolerance of plus or minus 0.5. Alrighty, so now we are ready to create the distance measurement showing the relationship between a couple of our bolt holes. So let's switch back to PolyWorks and get into this. So let's go ahead and put my part in a similar view as what the print has, and if I want, I can also make sure I'm normal to that plane. And let's come down here to distances and drop in a distance feature. I want to make sure that we follow the same distance that the print's asking for, which is this vertical distance hole to hole. And we can see right now I'm not able to easily create that distance feature. I'm kind of drifting off to an angle. That is because we are using the coordinate system to drop these distances. And typically when we work with CAD, we might be accustomed to having a coordinate system that's relatable back to the part, perhaps representing how the part is machined, or perhaps representing how the part's positioned in some sort of assembly. In this case, because I don't have a CAD, the coordinate system that we have came from the device I scanned this part. So it's not a very relatable coordinate system back to our part. So what we should do is create a coordinate system. So let me get out of create the distances, and let me go ahead and just quickly only show the features that I'm interested in. I want the coordinate system to lie on our bolt plane here, positioned at circle 1, but I also need to hold our tertiary clocking face. So let's go ahead and clock rotations. How about to this face here? So let's go ahead and grab that plane. Let me zoom in here to get a good selection of data. And we might have to switch our methods, or of course I could try to just select a different area of the data. There we go. So when you're trying to create these surface-based features, you just kind of have to work with the data and help PolyWorks out with where you select that data. But we can easily grab those surfaces, and let's go ahead and create the coordinate system. So I'm going to just go ahead and clock my coordinate system, lock it in tight. There we go. Now that we have our coordinate system relatable to the part, I can go ahead and take more advantage of my views down here to drop in those distances. So let's go ahead and bring back our holes and grab our distances. So the first distance is nominal value of 101 plus or minus 0.5. And we'll drop in our distance down here. That is 78.7 of plus or minus 0.5. Alrighty. So we have completely inspected this part to meet all the print requirements. However, my customer is still also asking for an inspection report to accompany the inspection. And I also probably want to build some sort of report for us so we can understand where we need to improve our production of the part to make sure we're passing everything. Well, even though we don't have a CAD model, there's nothing preventing us from still using all the tools we're familiar with in PolyWorks to analyze our results, such as taking a look at our controls in the control reviewer. We can see we get our deviations and our test, but furthermore, we can go ahead and easily create reports showing objects in the 3D scene. So let's go ahead and create a couple of these control views. Let's go ahead and combine my angle in a control view with the size of the hole here. And if I want some more real estate, I can close my geometry controls and we can take a look, and that's something that works for me. So let's go ahead and grab that, create control view, and we're gonna just call this the flange check. And then let's go ahead and grab the 4 holes and the distances, and as well as the flatness of the bolt plate. So let me go ahead and just get a nice view here. Let's hide our coordinate system so we can pop up the annotation for circle 1 and create that control view, bolt hole checks. And of course, default settings allow control views to populate our report. So if I go to my report, we can see we're getting full reporting capabilities, even though we don't have a CAD model. And of course, at this point, I could go ahead and continue refining my report to make it more presentable. But for today, I just wanted to show everybody that even if we don't have CAD, we can still, there's nothing stopping us from going through the review practices that we might be accustomed to. So as we have seen, I was able to build a complete PolyWorks Inspector project without needing a CAD model. This resides in the universality of PolyWorks, specifically how we can still practice the same workflows we've become accustomed to without having CAD models. This concludes our webinar on how to inspect a scan without a CAD. I'll turn it back to Carol for questions.
Thank you, Judge. We have time for one little question here. It is regarding the JD&T tools. So you have added a flatness earlier, but can we add any other type of JD&T tools, maybe a location tool, something like that?
Yes, that is a great question. Let's go ahead and take a look back really quick at my plane 3. So I was asked by the print to create a flatness control here, which is a form check. But if you want to take advantage of JD&T toolbox in PolyWorks, such as location tools, what we really require is to have nominal information for location checks such as position. So let's take a look at circle 1 that's now centered at my origin. suppose I needed to check position of this. I can come into circle 1 and I have to define the nominal primitive. Of course, in this situation, I could go ahead and take advantage of the center being 0, 0, 0, where my coordinate system sits, and I could enter a radius. But now that I have a nominal circle there created, now I can pop open the geometry controls and I can add my location tools. And that's simply because, sorry, position. And that's simply because, you know, in PolyWorks, when you're doing location checks, you need to know where the object should be located, and that's usually driven from nominal information. And then keep in mind, we may also want to take it further, and you need to make sure that we have nominal information for other things like our datums and things like that. So it can be done, but we just need to make sure we can feed that nominal information into PolyWorks.
Thank you, Joshua. And I see there are other questions that are coming in, so we will get back to you by email because this is all the time that we have. This webinar has been recorded. It will be available on the Innovametrics software website. Navigate to the About Us section. It will also be available on the Innovametrics software channel on YouTube. And we hope to see you at the PolyWorks Conference USA 2020 on April 15 and 16 in Novi, Michigan. This is the must-attend PolyWorks event to strengthen your essentials, explore new ideas, meet the user community, and grow your network while having lots of fun. Highlights include 3 launch presentations dedicated to demonstrating the new features of the PolyWorks 2020 digital ecosystem integrated within typical engineering and manufacturing processes. 2 PolyWorks Inspector technical workshops for all skill levels on core inspection tools and learning to be more efficient running the software. 8 polyclinic sessions to grow your knowledge of Muller Lite, Talisman, Report Loop, and SPC. One-on-one session with the PolyWorks expert in the doctor's office. Hardware exhibition to learn about the latest 3D measurement equipment, and much more. We do have an early bird rate, which ends on March 1st. For more information, visit our website at innovametric.com. Our next webinar is scheduled for March 12th, 2020, and we will be talking about how to use color maps as powerful investigative inspection tools. Thank you for joining us this morning, and we'll see you next time. Bye-bye, everybody.